Here's another image, and the last one before I want to talk to the material of this talk, which is also suggested by David Hawkins. On the left is the fact that we've taken 1 billion tons, 1,000 billion tons of carbon dioxide into the atmosphere by all the fossil fuel activity since we started doing it 200 years. Coal, oil, and gas, as in those three colors. It's 1,000 billion tons. You may remember 2,200 against 3,000 if you've got a spectacular memory. So 800 has been the growth in the atmosphere. 500 may have been due to that, and 300 from cutting down forests. So that's the total activity that we've done in the fossil fuel world. On the right is the emissions that are committed if we build the coal and gas power plants that we are now saying we will build globally between now and 2030. And you see that as much coal come out of the ground over the lifetime of those plants as came out of the ground for all purposes until now. And for gas, yet more. You have to assume a lifetime. I assume 60-year lifetime for the coal plant. And then the calculation just follows. The bad news is that's actually from a 2004 report of the International Energy Agency. When they got to 2006, they raised the amount of coal plant they thought would be built by 2030 from 1,400 to 1,800 gigawatts. They acknowledged a rush to coal in the world, not just the US, but Europe too. Relative to natural gas plants, probably the natural gas would be smaller. There's been the most unfortunate energy development exactly at the time that we're taking carbon seriously, namely a global rush to coal power. Coal is far more competitive with natural gas in the minds of virtually everybody who's in the electricity game than 3 years ago or 5 years ago. We built an enormous amount of combined cycle natural gas, as many of you know. Companies went bankrupt, stuff is mothballed or used fewer hours a year than expected. We have to solve a climate problem at the time when coal never looked more attractive. And the politics of this country is now recognizing the crash, the railroad crash, between the coal industry wanting to get a full share, including coal to liquids, and the realities of the climate problem. And what are the ways out? I didn't note before, so let me go this so you can see this. We're producing 8 billion tons of carbon or 30 billion tons of CO2, 7 billion of us. So our share is 4 tons of carbon dioxide emissions per year on a per capita basis. 1 ton of carbon per capita per year. So let's look at what activity generates that much stuff. Well, driving 10,000 miles a year in a 30-mile-a-gallon car will put 4 tons of carbon dioxide into the atmosphere. If you like, that's your quota on a global average at today's levels, before we bring the total down, before the population grows. Flying about a mile and driving a mile is about, if you're in a car alone and it's a 30-mile-a-gallon car, is about the same carbon emissions. Obviously, there's some fuss with that, but think about, so for many of us, our flying just dominates our carbon footprint. But have that in mind. So if you fly 10,000 miles, you've used up your quota too. My home in an average New Jersey climate, efficient furnace, not a particularly large house, many houses in this ballpark, it's also going to emit 4 tons of CO2 a year. I use up my quota that way. I share it with my wife, so then it's not quite a full share. 300 kilowatt hours, this is the number I want you to remember. 300 kilowatt hours a month from coal power is that same share, 4 tons of CO2 per year. So most of you have electric bills of 1,000 kilowatt hours or more per month. You're using up 3 times your share from that activity alone, divided by the number of people in your home. So 300 kilowatt hours a month is an interesting reference point, equivalent to the carbon emissions that we have on a per capita basis on the assumption that it's all coal. And of course, nobody said this earlier in the meeting, but if you're thinking about carbon, the carbon intensity of the power, where you are saving that electricity, really matters. And in New Jersey or in the US average, it's about double the carbon, about half the carbon emissions of pure coal is the carbon emissions of the electricity system, thanks to hydro, thanks to nuclear, and thanks to gas. So then it would be 600 kilowatt hours would use up your quota in an average environment. You've got to know what it is. And you've got, in California's case, they have a way sometimes of not including the carbon in the imported electricity. It matters whether you do or not.